All right. Well, thank you for joining. We've got an awesome session today called Talk to Wikipedia with the folks over at Deepgram. Before we get going, some quick housekeeping. If you have any questions, you can ask them on the right-hand side of the screen. We will answer as many questions as we can during the session. Anything else, we will answer at the very end. We will be recording this session. No need to ask us for the recording. We will email everyone who registers at the very end. So to kick things off, I'm Alex. I work on the product team at DataStax on generative AI. Peter, it'd be great to hear a little bit about you.
Hey, I'm Peter Griggs. I'm a technical product manager at Deepgram.
Awesome. And Peter, you are very new at the company, right? This is week 8 or something like that?
Yeah, this is the start of week 8 for me at Deepgram. Prior to this, I founded and was running an AI software company called Deep AI for the last 6 years.
Awesome. Well, we're super lucky to have you here and super excited to walk through what you and the team have been working on. It sounds like the past couple months.
Great
So
to be here.
Peter,
Thanks for having me.
for sure. So Peter today is going to give a really cool demo of a real-time voice assistant. And then we're going to walk through how exactly one would build something like that using Deepgram technology and the vector store from DSLMs. So Peter, maybe to start, you can tell us a little bit about Deepgram.
Yeah, so Deepgram offers the world's fastest and most accurate speech-to-text AI models via an API. And they also offer a bunch of domain-specific language models and the fundamental building blocks for language AI applications.
Very cool. And what sort of demo are you going to show us today, and what sort of Deepgram tech does that use?
So I'll show you what my team at Deepgram has been building as of late, and what we used DataStax, AstroDB, vector database for as a part of the retrieval system. And we'll go deeper into this after the demo, but basically we have Deepgram's speech to text, doing real-time speech to text on on the taking your transcripts into the demo, sending them to a large language model, getting additional information from the vector DB, doing similarity search, passing the initial prompt and that additional information back to a large language model, and then returning that back to the user with text-to-speech, so with generated human speech. So you have, at the end of the day, a real-time voice-to-voice AI chatbot.
Very cool. So I'd love, maybe we get right into the demo.
Yeah. Okay, so this is our Wikipedia agent with all of the knowledge of Wikipedia at its fingertips, thanks to AstroDB.
Hi there. Voice chat. Knowledge. Wikipedia.
Hey, can you tell me about the plant known as Indian pipe in the Olympic National Forest, the one that doesn't have any chlorophyll?
The Indian pipe, also known as Saprophyta, is a unique plant species native to the Olympic National Forest in Washington state. It is a parasitic plant that lacks chlorophyll and relies on fungi for nutrients. The plant's flowers are typically white or pale yellow and bloom in late spring or early summer. It is an important part of the forest ecosystem and plays a role in the decomposition process.
All right, let me keep going then. Interesting. If the plant doesn't photosynthesize, how does it get its nutrients?
The Indian pipe is a parasitic plant that relies on a specific type of fungus for nutrients. The fungus forms a symbiotic relationship with the plant, allowing it to absorb nutrients from the fungus's mycelium. This relationship is essential for the plant's survival, as it does not have the ability to photosynthesize like other plants.
Very cool. And what about Genghis Khan? Tell me about Genghis Khan and the territories that he conquered.
Genghis Khan, born in 1162, was a Mongolian warrior and leader who went on to become one of the most successful conquerors in history. He founded the Mongol Empire, which at its peak stretched from Eastern Europe to the Pacific Ocean. Genghis Khan was known for his military ruthlessness, and his empire was built on a system of meritocracy and loyalty. He died in 1227, but his legacy lived on through his descendants, who continued to expand the empire for centuries to come.
And what do modern day scholars think of Genghis Khan?
Modern-day scholars have mixed opinions about Genghis Khan. Some view him as a brutal conqueror who caused immense suffering and destruction, while others see him as a visionary leader who brought unity and prosperity to a vast and diverse empire. Many historians acknowledge his military genius and the efficiency of his administration, but also recognize the harsh methods he used to maintain control. Overall, Genghis Khan's legacy is complex and continues to be a topic of debate among scholars.
All right, so as you can see, wealth of Wikipedia at its fingertips relatively quickly. And I think it's important to note one of the largest drivers of some of the chat turnaround time wait is just the amount of characters and tokens sending to the LLM. So we're taking really large bodies of text from Wikipedia along with our questions, sending those to the LLM in parallel. So you have really large input responses and fairly small completions coming out of the large language model. But I think that's the biggest driver for some of the weight there.
Very cool. This was awesome. And you said the first couple of questions were inspired by a hiking trip, right?
Yeah. I was hiking in Olympic National Park a few years ago, I think still during lockdown, and found this like very pale plant growing on the ground, and was like spent some time trying to figure out what it was, and like doing what you'd normally do, like Googling pictures of it and trying to figure out the name, and then finding a Wikipedia article, realizing that it's a parasitic plant that doesn't photosynthesize and lives off of the host tree that it's at the base of.
Very cool. Do you mind stopping the screen share, by the way? Awesome. So maybe to start, could you walk us through the architecture of the demo you just showed?
Yeah, so we have a pretty standard backend web application. In Next.js could have been done in Fast API or any Python backend as well, doing a number of things. So the core app serves a front end that opens up a WebSocket, hijacks a mic to capture your audio. And then this is when the more interesting things start to happen. So we use Deepgram's automatic speech recognition API. So you can see like sort of how quickly the results are coming back from that across the screen. It's practically in real time for speech to text. We then take that transcript from the user and we send it, we convert it into an embedding using another large language model, or at least the base of it. And we send that embedding to AstroDB's vector database that I think has about 100 million plus vectors within it of the same embedding dimensions, and from that same base model. And we do effectively cosine similarity using an approximate search to find all of the vectors that are most similar to that vector in vector space. So we're sort of taking like in vector space, like what are the things in Wikipedia that are the closest to what the user spoke about. And then we take those responses back and we pull in the metadata for those vectors, which is the bodies of the text from Wikipedia that had been vectorized. We then combine that with the original user transcript that was converted to text and send it to the large language model, and somewhere along in some fashion, like, hey, here's some additional information that might help you complete my prompt, and then here's my prompt. And then that language model has its context window, all of this additional information from Wikipedia. We take that response back from the large language model, and then we use text-to-speech to synthesize that text into human speech.
Insanely cool. So I guess a lot of the work of calling the LLM and the vector store, is that done in serverless functions?
Yeah, effectively. So these are all internal building blocks at Deepgram. So if Deepgram's Deepgram has a base like foundation chat LLM plus their base automatic speech recognition model, and then and calling those from that serverless application effectively.
Okay. Very cool. And so this is really just super advanced prompt engineering, right? Like there's no sort of fine tuning you're doing. Is it just prompt engineering?
The underlying model has been fine tuned to be exceptionally good at conversational chat, and you can see that in comparison to the way it performs to something like ChatGPT or Claude 2 from Anthropic. And that is, I think, like one of the things that's unique about Deepgram is like the wealth of experience they have with like real world human conversation and voice data. And so other than that, no, the model was not fine tuned like for this Wikipedia task by any means. The only thing specific to that is the retrievable system.
Very cool. What are some of the key use cases for voice interaction?
You mean specifically for large language models and artificial intelligence?
Exactly. Yeah.
Yeah, I think like there's a bunch when you start looking around the world at like how much of it we interact with our voice compared to text. A bunch of things start to come to mind immediately. You have like everything from like the way we place orders when we go through like a restaurant. You have the way you get help when you call a company or your bank and you reach out to customer support. Things like as you go through your day-to-day life and you start thinking about some of those larger applications that can the way you interact with the world, like those start to come unearthed. But I think those are some big ones.
Very cool. And is this demo app using LangChain or any other orchestration framework?
No, we didn't end up using LangChain for this. I've used LangChain personally for side projects and works great, but no, for this backend is written entirely in JavaScript. Could have very well done the same thing with LangChain for some components of it. And then otherwise it's just a standard web app, but built on top of some really awesome language AI building blocks from Deepgram and DataStax.
Awesome. Yes, so you're just interacting directly with the Azure Vector Store using like our Node.js driver, right?
Correct. Yeah. So we use that Cassandra driver npm package and query directly from there using the Cassandra query language.
Got it. Very cool. Is there any reason you're not using LangChain? Do you think it's easier to build applications without LangChain, or what are the thoughts?
I think it's just like with anything when you're picking the tools you want to use for an application, like pick what's going to make it easiest to build and going to scale with you. And I think for us, like, we very well could have used LangChain for, I think AstroDB, I think y'all have an integration there. But since we weren't using it already, it was just another tool to add that we didn't really need to use. Like at the end of the day, like we were writing a basic JavaScript function to call out to your DB and back. And we were already using other tools internally to convert the text transcripts into embeddings to send to your DB. So LangChain's a great tool. I'm a LangChain fan. I think it's great, and especially I think a lot of these a lot of different sort of like frameworks and packages can really help you get from 0 to 90% really, really quickly, and can be great to lean on.
Cool. And it'd be good to hear from you. Why is a vector store needed for this sort of use case?
Yeah, I think this is a really important question because it's easy to get lost in using a lot of the latest tools and forget to ask yourself, like back up and from a first principles perspective, ask yourself like, okay, like why am I using some of these things? And these vector retrieval systems or vector stores, when working with large language models, have two primary benefits in production out in the wild. One is that often you would want to fine tune your underlying model. We didn't for this specific application, but real world data changes between larger underlying training runs, whether they're foundational or fine tuning, and it's much easier to update your vector store than it is, to go retrain your entire base model. And so that can function as a way for you to have the latest information constantly up to date as it changes, whether it's within your organization or out in some other application, and have the model have access to it just by injecting it directly in the context window through real-time usage. The other is that, like, even with a fine-tuned underlying model or heavily trained foundation model for specific, like including data for specific applications, you can still see some hallucinations in these large language models. And having a vector store supporting that context in real time can help reduce the percentage of the time that you see hallucinations.
That makes a whole lot of sense. And like, how do you detect hallucinations and test for them?
Yeah, I mean it's a good question. I think it depends on like the scenarios you're in and what you're testing against. So like and how we're sort of defining hallucinations. If you're talking about like I think like trying to test for the quality of a model's response to a human conversation context, there's a lot more like you can have a much higher range of outputs from the model that are correct for the human's perspective. I think if you're talking about like a more QA-based scenario that we see a lot of people maybe like using ChatGPT for example, it's a lot of scenarios, but if you take a QA-based scenario, it's a little bit easier to grade like the hallucination on that. Like there were facts that were presented that were either correct or incorrect. Some people use, and for these scenarios, like rogue as an accuracy technique. It's not specific to hallucinations, but like how close was the response in terms of bigrams and trigrams to like what we would consider a gold standard response. From my experience, most of the time hallucinations are detected through like human usage and grading of the model, and you start to find places where the model produces errors with some frequency, and then you will go back and fine tune or use some reinforcement learning to help improve the underlying model.
Got it. So there's a lot of this kind of evaluation of responses from the LLM, like manual review, like can it be automated? How do you think about that?
Yeah, there's still a lot of this, especially in conversational settings, is manual. And at the end of the day, like taking like a range of human feedback and trying to align the model with that human feedback tends to still be one of the better approaches. There are scenarios in which you can do some programmatic ranking of model responses, like with something like Rogue, where you're looking at the recall, the model's ability to correctly match a certain number of bigrams and trigrams against a gold standard response. But again, I think there's scenarios, especially in human conversation, where the amount of variation that's acceptable is so high that a model might produce really poorly, even against a set of like 20 or 30 gold standards that you would measure it against programmatically, but like a human perceived it as like totally fine and normal and accurate. So I think that it becomes more nuanced when we're talking about like human conversation versus just like factual content.
Got it. And besides kind of testing response quality, what other things should you think about before putting an app like this into production?
Especially for voice to voice, latency becomes one of the biggest drivers, and I think both the latency that you generally perceive and thoroughly testing that latency for variation can be really important, because sometimes if you have like some, for whatever reason, some large variation in latency, you can start to break down like the sort of real-time feelingness of your interactions. Now with this was sort of like an outlier because we're taking such a large amount of text where like latency wasn't a huge concern. So we wanted to like show how like the scale of which you could work with these vectors. So we added some seconds of latency just cramming large amounts of information in the model. But normally, I think before deploying an application like this, that's certainly one of the largest considerations. I think the second is like looking at, is your underlying model fit for the task where a retrieval system is going to give it the missing context it has to then succeed at the task, or do you also need to fine tune your underlying model? So, and that which changes the scope of the project and the work before deploying it significantly. So I think like if you have a pretty good base chat model, like say you go take some open source chat model like Giraffe from Abacus, or with a longer context window than Llama, or just the regular Llama 2, like those might perform really, really well for a lot of tasks, but miss some context. And so you can add in a retrieval system like a vector database, and it will start to do just fine. Given the additional context, you might find scenarios in which those models don't perform that well because of the way they were trained. And you might need to fine tune that model with some conversational data, or question answer pair, or prompt completion data, however you want to say it, for it to work better.
Got it. And are there any kind of like security or data protection components you think about before, a production deployment?
I mean, like as a developer in general, or specifically as a company like Deepgram?
Maybe as a developer in general. Like what sort of things do you think about?
Yeah, I think like there's a lot of debate around like who owns the content that is generated with a model, and concerns around how much open source data, or sorry, how much public data that was scraped that belongs to companies and that was scraped against our terms of service were used in those models, how much artistic information went into it that the model was going to replicate, and is effectively like not as original, not fully original. So I think I think that's like a general concern, especially with taking open source weights, specifically to like the data you're putting in models. I think just same data constraints as we have in the industry today. Like be mindful of whose data you're using, and do you have the license to use it to feed it into the model? And your future self will likely thank you.
Sure, absolutely. And probably most relevant to what DataStax does, you have a ton of experience with vector source, right? We talked a little bit before this, but you've been using vector source for a very long time. What are kind of the most important pieces to look for when choosing a vector database?
There tends to be like four concerns, some of which are like fundamental in terms of performance, and some of which are convenience for the end developer. I'll start with some of the convenience things that I find to be like really nice. One is like I want to be able to do the least number of round trips possible to the vector database and get the information that I need. And two is like I want to be able to associate metadata with my vectors really easily, and also do that without necessarily increasing the number of round trips, especially if like latency is a concern of mine, and just like ease of coding. So again, some of this is like not super fundamental, and some of it's like just application simplicity thing, or just like an ease of coding thing. But so I look for features related to those that are just, and these are sort of like nice to haves. So you see this with like a number of vector stores, and with AstroDB as well, where like I can query for both the closest vectors and some specific associated metadata. So I get like my vector list back, but I also get, or the IDs for the vectors back, but I also get like that associated metadata. So I don't have to go do like multiple calls to go back and like say like, okay, cool, I found my nearest neighbors. Like now let me take these IDs and let me go like look up some metadata and do like a second query. And so, yeah, especially in environments where like you do care about saving 50 milliseconds of latency or something like that, I think like reducing, even if it's 30 milliseconds, like reducing round trips is nice. Fundamentally, the stuff that I look for architecturally is like, what's the scale of vectors that this vector database can handle without me seeing an increase in latency? So that matters a ton, because like if I'm working with 50,000 vectors today, like I might be working with 10 million vectors tomorrow in that same application. And I want to make sure that like the architecture that I choose and the vector database that I'm using are going to be able to work for that. And the second then just becomes about like cost versus management overhead. So like, am I using a hosted database or am I home rolling like PG vector on my own? And that's like a standard developer question that we all ask. Yeah, I think that's fundamentally it. And some of those are just standard engineering questions you would ask with both things. But being mindful of the increase in latency as you scale with your vector database, I think is important. The other thing I'll bring up too that is not specific to the vector database, but just in working with vector databases is like thinking about the quality of the embedding that you're creating and the embeddings that you're searching against. And so whether you're like if whether you're using some contrastive model like Clip to take text and search for images, and those have been projected in the same space by the model, or whether like you want like just this like the craziest highest dimensional text embedding you can get, or like whatever it is, just making sure that like the underlying embeddings that you're starting with are fit for the task that you want to use them for, and are going to give you the best results. And now, like especially as of the last year, there's like so many options for embedding generators for text and for images that like you're hard pressed to miss on that.
I can't remember what embedding model we used for this. Do you remember by any chance?
Yeah, we used actually like a pretty basic like BERT multilingual V5 model that was in sentence transformers Python library.
Right. And the reason we chose that was when we were indexing all of the Wikipedia data, this is like the fastest embedding model, right? Like the bottleneck when you're loading a ton of this embedding data is generating the actual embeddings. So this ranked as like the #1 fastest to do something like this.
Yeah, it's a perfect example of picking something that fits for the task that you have, and the embeddings are of high enough quality and richness that like you still get like you could get matches, and the dimensions were I think like half of some of the other embedding models as well. Like the dimensions of the output vector, I think were like half the size of other models as well.
Awesome. Well, I think that's all the questions we had for you. Really appreciate you joining and all the hard work your team put into this demo. And we will now take questions. If anyone has any questions, feel free to plug them into the chat.
Thanks, Alex. Appreciate you having me.
Awesome. Thank you.